So Volker, I think there seems to be a trend towards these kinds of heterogeneous systems built around the RISC-V ISA, where essentially RISC-V could be anything you want it to be. It could be a TPU, an NPU, a CPU. What is Semidynamics' approach to, an architectural philosophy for using RISC-V?
Yeah, thanks, David. In Semidynamics, we are one of those to aim to put heterogeneous functions together, but under a single RISC-V instruction flow. And that's the beauty of RISC-V as such, that you have a degree of freedom to interpret the ISA the way you want. In this case, it's the RISC-V plus the vector ISA and other extensions. And the key point in our approach is actually that we try to make a very efficient design, combining the heterogeneous, say, instructions into a single engine. We call that all-in-one.
The main thing that you hear here at Embedded World in Nuremberg is about memory. Everybody has different thoughts about how to handle memory in an embedded system. I understand Semidynamics has bespoke memory handling technology. Can you tell me a little bit about that?
Well, yes, thanks. In terms of memory, the issue is, especially when you move a lot of data, huge amounts of data in vector databases or in the context of AI, regardless of what your design may be, this data somewhere comes from a slow storage and goes via DRAM to wherever you need it. Right? And that is the key point. There is a thing which is the external memory interface talking to the DRAM, and there is a limit as to what you can buffer typically, and that's the so-called L1 cache, or in other systems it's L2 cache, but you will have cache misses. And that's the point where the processor takes a waiting position and waits for the memory to respond, which is many cycles away. Typically, not in our case. In our case, we can handle up to, in the standard configuration, up to 128 cache misses for the DRAM requests. And typically the DRAM is 100 cycles away. It means our machine will never stop working. We can go on making requests, we will never stop working, and we call this gazillion misses.
Excellent. There's a lot of interest, I think, in the EU right now in how do we have a more sovereign approach to AI. And I know that's something Semidynamics has been thinking about a lot. What do you think can be done?
Well, as far as we are concerned, we are exploiting RISC-V ISA to this maximum extent. It means we are doing AI, or we are enabling AI, more or less exclusively with RISC-V ISA. That means everybody who uses our IP or the IP in the chip, whatever, they can see everything that happens in this chip. And they can use, for instance, software to do their own stuff. The bottom line is, they then have the total 100% control of that software with an open ISA, and they don't have to ask anybody for help. We are here to help, we are happy to help, but if they want, some customers are very keen on doing own stuff without asking for help, they can. I believe we are the only ones where that is the case.